In this video, we are going to learn how to use Pythagoras to determine different properties of triangles. And we are going to discuss three types of triangles. The first one is a right-angled triangle. Remember, in order to work with Pythagoras, we need a right-angled triangle. The second type of triangle that we have is an obtuse angled triangle. That is a triangle with one angle bigger than 90 degrees. And the third type of triangle is an acute angled triangle. That's a triangle with all three angles smaller than 90 degrees. So we can apply the theorem of Pythagoras to determine whether or not a triangle is right-angled, obtuse, or acute angled. Let's take this triangle for example. I have three lengths, 8, 11, and 16 units, and we want to determine whether or not this is a right-angled triangle. So the theorem of Pythagoras said we take the longer side squared and we need to place it equal to the sum of the shorter sides squared. So I place the longer side, 16 squared. I don't put it equal yet because I'm not sure if it is. So I put it next to 8 square plus 11 square. When I simplify, I find that 16 square is 256, 8 square is 64, and 11 squared is 121. And if I add these two together, that is 182. So 256 is not 182, but it is bigger than 182. Because the length of the longest side in the triangle squared is not equal to the sum of the two shorter sides squared, we can say that that triangle is not a right-angled triangle. But also because the length of the longer side squared is bigger than the two shorter sides squared, we know that that triangle is an obtuse angle, meaning the angle opposite the longer side squared is bigger than 90 degrees. We are going to apply Pythagoras again to determine whether or not this triangle is obtuse angled, right angled, or acute angled. And I apply the same rule as before. So if I consider Pythagoras, I would take the longer side squared and I would compare that to the sum of the two shorter sides squared. So 5 squared compared to 4 squared plus 3 squared. If I simplify, I see 5 squared is 25, 4 squared is 16, and 3 squared is 9. And we find that this is also 25. So the longest side squared is 25, and the sum of the shorter side squared is also 25. That tells me that this triangle is a right-angled triangle, and the angle opposite the longest side is the right angle, or 90 degrees. In our last example, we want to determine whether this triangle is right-angled, acute angled, or obtuse angled triangle. So what I do, I take the longer side squared and I compare it to the sum of the shorter side squared. So I apply Pythagoras. It is not equal to yet, we need to first compare. So 7 squared will give us 49, 6 squared is 36, and 4 squared is 16. But now we see that this adds up to 52, and 52 is bigger than 49. Because these two are not equal to each other, we say the triangle is not a right-angled triangle. But because the sum of the shorter side squared is 52 is bigger than the longer side squared, this triangle then is an acute angled triangle.